Question 3. The ionic product of water Kw is equal to 2.93 times by 10 to the power minus 15 moles to the power of 2 dm to the power minus 6 at 10 degrees Celsius. Which is the correct expression for Kw? Definitely not going to be A. It's got H2O. Constant, definitely not going to be B. And definitely not going to be D. The answer is C. And you'll get the hang of it once you just literally put in 2 hours into the topic of Kw, maybe even 10 minutes, and you'll quite easily identify that this is the correct expression for Kw. Calculate the pH of pure water at 10 degrees Celsius. Okay. How would we do this? Well, we know that this is the correct expression. We've got Kw equals H plus OH minus. Now what we can do now is therefore we can say, assume that Kw is equal to H plus squared. Therefore H plus is equal to square root of Kw. And what's Kw? It's that. Multiply of 2 dm. So we're going to do square root of 2.93 times by 10 to the power minus 15. Square root of 2.93 times by 10 to the power of minus 15. 0.41 times by 10 to the power minus 8. Now this gives us the concentration of H plus. We don't want that, we want the pH. Well, we can use the equation pH equals minus log 10 H plus, and therefore pH is going to be minus log 10 of my answer, which is going to be 7.27. 7.27. Suggest why this pure water at 10 degrees Celsius is not alkaline. Why it's not alkaline? Well, because we know H plus is equal to OH minus. Or we could say equal moles of H plus and OH minus, but I feel like this is the approach the examiners want you to give. The idea that H plus is equal to OH minus. 3.4 and 3.5. So 3.4, calculate the pH of this solution of calcium hydroxide at 10 degrees Celsius. So well, we know to calculate pH we need the H plus, obviously. So how do we find H plus? Well, we know H plus is Kw over OH minus. In this part it's going to be that Kw over OH minus. And how do we find the OH minus? Well, we know OH minus is equal to 0.0131 times by 2. Yeah, times by 2. because calcium hydroxide CaOH squared. So we're going to times it by 2. I'm pretty sure that's the reason we're times by 2. And we get 0.0262. Therefore, H plus is equal to Kw 2.93 times by 10 to the power minus 15. 2.93 times by 10 to the power minus 15 divided by OH minus, which is 0.0262. 0.0262. This will give me 2.93 times by 10 to the power minus 15 over 0.0262. 1.12 times by 10 to the power minus 13. That's a concentration of H plus. Therefore, to find a pH, pH equals minus log 10 of H plus. Therefore, pH is going to be minus log 10 of 1.12 times by 10 to the power minus 13. So we get pH as minus log 10, 1.12 times by 10 to the power minus 3, and we get 2.95. Perfect. 2.9. Actually, I must have done. Did I do that correctly? 2.93 times by 10 to the power minus 15 divided by 0.0262. 1.12 times by 10 to the power minus 13, and then pH is equal to minus log 10 of my answer 1.12 times by 10 to the power minus 13, 12.95, sorry, 12.95, and that is to 2 decimal places, and that is the pH of a solution. And then 3.5, predict whether the pH of the magnesium hydroxide is larger than, smaller than, or it's the same as the pH of calcium hydroxide at 10 degrees Celsius. So the pH of calcium hydroxide is 12.95. Let's just do it here. 12.95 is pH. Explain your answer and then explain it. So magnesium hydroxide. Magnesium hydroxide. When we know magnesium hydroxide is sparingly soluble, will that help us in this question? Yes, it will. Sparingly soluble, aka less soluble. We could say less soluble. So it's going to be, so put this here, put this here. The pH of magnesium hydroxide compared to calcium hydroxide. Let's just write down. It's going to be lower pH, as magnesium hydroxide is sparingly soluble. And we know that the solubilities of hydroxides increases down group 2. Solubility of hydroxides increases down group 2. And that is the end of question 3.